Okay, so we're going to start adding and subtracting polynomials. So this first one is asking us to find the sum. So I'm going to take my my polynomials that I'm given. I'm given two polynomials, and I'm going to put them in order and group them based on their like terms. So I'm going to also be working on getting these into standard form at the same time. So I'm going to take this first piece, or the first polynomial, and we have 2y to the fourth. And then I'm going to section out different parts because we're going to line everything up in group. So this section will just be for my y to the fourths. Then I'm going to have a section for my y cubes, my y squareds, my y's, and my constants. And we're just going to kind of split those up. So our first one we had was the 2y to the fourth. I already moved that one. The next one is going to be negative 5y squared. So I have a spot for my 4s, my 3s, 2s. So let me put these up. So I have a spot for my 4s, 3s, 2s, 1, and my constants. Okay. So because we're at negative 5y, I'm going to go to where the degree is 1, and I'm going to put a minus 5y. Okay. And then finally for the constant, so this one's done. My 1 is going to go here, so plus 1. Okay, so we use that one. Okay, next we are adding, so now we're going to throw in the next group. So I'm going to throw in a line here. We have 3y cubed. So I don't want it with my 4s, I want it with the 3s. So 3y cubed, and then we have plus a y squared, so that's going to go in the y squared section, and then a minus y, so that's going to go with my y section, and then my constant is a minus 4. So we're organizing these to line up together. Okay? And then I forgot to cross those out as I was going, but there's that. So then your final answer is what happens when we take all of these and we add them together. So I have my 2y to the fourth, it's not being added with anything, so we just get 2y to the fourth. And then we have nothing on the top, plus 3y cubed, so we just get plus 3y cubed. Okay, next one, we don't have anything on the top, and it's being added with y squared, so we'll add that together. Next one, we have a negative 5y plus a negative y. So that's going to give us a negative 6y. And then finally we have our constant. So we have a positive 1 plus a negative 4. So that's going to give us a negative 3. And then this right here would be our final answer. Let's go ahead and look at what happens when we subtract. So same idea, but there's one slight step that we have to do at the beginning, and that's going to be to turn this into addition by distributing the negative 1. So because we're subtracting, we have this little negative 1 that's hiding here. So we're going to go ahead and distribute that to everything that's being subtracted. So this entire polynomial is being subtracted. And we're going to create a new polynomial addition problem. So we're going to have 3x to the fifth minus 4x to the fourth plus 12x squared plus 10. We distributed our negative 1, so this is now an addition problem. And then we're just going to multiply. Negative 1 times 5x to the fourth is negative 5x to the fourth. Negative 1 times a positive 9x squared is a negative 9x squared. Negative 1 times negative x is a positive x. And then negative 1 times a positive 8 is a negative 8. And so now we have a brand new problem, but now with addition. So now we're going to do our same thing. Our highest degree is 5. So I'm going to create groups for 5s. So this would be the 5th degree, the 4th degree, 3rd degree, 2nd degree, 1st degree, and then of course our constants. Okay, so for my first set, I have 3x to the fifth, so I'm going to put that with the 5th degree. So 3x to the fifth minus 4x to the fourth And then I have a plus 12x squared, so I don't want to put that in the cubes. I want to put that all over here with the squareds. And then a plus 10 is my constant, so plus 10. Okay. And then in the next row, we're going to put our second polynomial. So I have a negative 5x to the fourth. That's going to go with my fourth degrees. Then I have a negative 9x squared. Okay, I have a positive x. And a negative 8. So minus 8. And we're going to go and add those up together. So we get 3x to the fifth plus nothing, so 3x to the fifth. Negative 4x to the fourth plus a negative 5x to the fourth. That gives us a negative 9x to the fourth. We don't have any cubed terms, so we're going to skip that one. Our squareds, we have a 12x squared, positive 12x squared, plus a negative 9x squared. So that would be 3, positive 3x squared, plus sign. Our x values, we have just the 1, so plus x. And then our constants, we have 10 minus 8, which is 2. Okay. So I'm just going to rewrite our final answer off to the side so we can kind of see it all together. We have 3x to the fifth minus 9x to the fourth plus 3x squared plus x plus 2 as our final answer. So we created an addition problem by distributing our negative, and then we just added together those like terms. The same thing can be done with our complex numbers. So here I have two sets of complex numbers. We're going to add and we're going to subtract. So I'm not going to make that little table that I just made. I'm just going to look for those like terms. Okay. So for the first one, we have a negative 7 and a 5 as our whole numbers, our real number part. So negative 7 plus 5, that gives us a negative 2. So that was our real parts that we just added together. Then our imaginary parts, we have a positive 2i and a negative 11i. So we have 2 plus negative 11, which gives us a negative 9i. And then that would be the answer for this one. Okay, so our real part and then our imaginary part to make our complex number. Okay, the second one, same idea, except now we are subtracting. So we need to take that negative 1 and distribute it just like we did on the last problem. So this problem is now going to become 18 plus 27i plus, because we distributed the negative, negative 1 times 2 is negative 2. Negative 1 times a positive 3i is a negative 3i. And now we can just add everything together. So first, the real parts. If we just look at the real parts, we end up with 18 plus a negative 2. So that's going to be a 16. And then our imaginary parts, we have a positive 27i plus a negative 3i. So that would be positive 24i. And that would be our complex answer.